Okay, we're going to expand our knowledge of trigonometric identities. I'll remind you of the ones we've already seen: the ratio identities, reciprocal identities, reduction identities, and most important, Pythagorean identities. The second most important identities after Pythagorean are the sum and difference, and these are actually the only identities that I'm not going to derive for you. I have a very good reason for that. The derivation of these is incredibly complex and beyond the scope of this course. So these are straight up memorization. Sine of A plus minus B is the sine of A times the cosine of B plus or minus the cosine of A times the sine of B. And cosine of A plus minus B is the cosine of A times the cosine of B minus plus the sine of A times the sine of B. Now, a word about the plus minuses. These are the sum and difference identities. There's actually two identities inside each one. If you choose the plus, which is on top, you'll choose the plus, which is on top. Whereas down here, if you choose the plus, which is on top, you choose the minus, which is on top. So if you pick the one on top, you always stick with the one on top. As an example of using these, we are going to compute the value of sine of 15 degrees directly. Now, 15 degrees is not a unit circle value, but I can write it according to these, based on unit circle values, by writing it as the sine of 45 degrees minus 30 degrees. And 45 and 30 are both unit circle values. So now I'm going to use the sum and difference formula to transform this into the sine of 15 degrees times the 45 degrees times the cosine of 30 degrees minus, because I chose the minus here, so I'm choosing the minus here, the cosine of 45 degrees times the sine of 30 degrees. Okay. Now these are all unit circle values, so I know what they are. This is the square root of 2 over 2. This one is the square root of 3 over 2 minus the square root of 2 over 2 times 1/2. Okay. And then, of course, we can clean this up a little bit. We get square root of 6 over 4 minus square root of 2 over 4, or square root of 6 minus square root of 2 all over 4. Okay. We're also going to use these identities to derive another set called the cofunction identities. And these are actually where the trigonometric functions get their names. Why cosine is cosine and not co something else. Okay. So, for instance, consider the sine of 90 degrees minus x. I can use the sum and difference identities on this to get sine of 90 degrees cosine of x minus the cosine of 90 degrees times the sine of x. And 90 degrees are unit circle values. Sine of 90 degrees is 1. Cosine of 90 degrees is 0. So this turns into simply the cosine of x. I could do something similar with the cosine of 90 degrees minus x, which will be cosine of 90 degrees cosine of x plus sine of 90 degrees sine of x. Once again, cosine of 90 is 0, sine of 90 is 1, so this turns into sine of x. So our first two cofunction identities are sine of 90 minus x is cosine, cosine of 90 minus x is sine. We get something similar for all the rest. Secant of 90 minus x is cosecant, and cosecant of 90 minus x is secant. And similarly, tangent of 90 minus x is cotangent, and cotangent of 90 minus x is tangent of x. So this explains why they have the naming system they do, even though most people would assume that, for instance, sine would go with cosecant instead, because they are related to each other.